So most power stations in the United Kingdom, or the Western world I suppose, or the rest of the world, are thermal power stations. Now thermal just means that something is burned to produce heat. A fuel, I should write, a fuel is pretend to produce heat. There are other types of power stations, namely nuclear power stations, where we don't burn a fuel, we use nuclear fuel, which is not exactly the same process. Have a watch of the nuclear power videos to understand that one so much. But all thermal power stations use a similar kind of setup, and I'm going to attempt to draw it here, and it's going to be very bad, so I apologise for that, but it shouldn't, hopefully the idea should come across. Now all thermal power stations start with some kind of furnace. Okay, now the furnace is where something is burned. So we burn the fuel. Now that fuel is often coal or oil or gas, but increasingly in some parts of the world it's becoming biofuels such as wood or biomass or that kind of thing. Okay, now we burn fuel, and that obviously produces heat. This is going to get very cloudy diagram, so I do apologise for that. It produces heat. Now that heat is used to boil water in the boiler. So the heat boils water. Okay. Now when I boil water, I make steam. And if I boil it in a container like this that hasn't got many openings, I make very high pressure steam that's got a lot of power and, well, a lot more kinetic energy. Okay. Now the steam shoots through to here. And that steam is really helpful because that steam can go on to spin a turbine, and these are really badly drawn, so I apologise. They look a little bit like those wind things you might have had on the beach, which is like, well, a wind mill, I suppose is the word. They work like windmills. So the steam comes along and it makes the turbine spin. This is the turbine. It boils the water, which spins. Now most electricity generation relies on this next step, a turbine spinning. Now the spinning turbine is attached to a generator, and we've already looked at what a generator is. The generator is simply a coil of wire, badly drawn coil of wire, inside a magnetic field, which spins. So the turbine spins, and that spins a generator. This is called the generator. And we know that that produces electricity. This is the main step. So all of this is done so we can spin the coil of wire in a magnetic field and produce the electricity. We want to spin it as fast as we can because that's how we get the strongest electricity we can. Now the electricity, I've got two really makeshift wires here. The electricity is then taken to a step-up transformer. Okay, this increases the voltage, and why that's important, have a look at the national grid video, but it's really important, otherwise we wouldn't really have great electricity at our homes. And finally, it's transferred to the national grid to be carried around the country to your house. And I've got a picture of a pile on there because that's probably the most iconic picture of the national grid. So that's all that a thermal power station really is. There's two little things I want to show you just quickly over here, and then we'll go through it one more time, nice and quickly. So the first thing is that with the furnace, if you're burning something, you're going to produce smoke. So you have a chimney. This is just a chimney for all that carbon dioxide and smoke and sulfur dioxide, etc. to come out of. It's not a great part of thermal power stations. This is a big problem about thermal power stations. They produce carbon dioxide, which is a very bad thing because that contributes to global warming and the greenhouse effect. There's also these things that you might have seen around and about if you've ever gone past a power station. This is a cooling tower, and this just means that we don't have to use loads and loads of water. So we boil the water, it becomes steam. Now the steam will cool down here, and well, it's sent to the cooling tower. It cools down, and it becomes water again. And that water can then be pumped back into the boiler to then be boiled again and carry on. So it means you're not using more and more water. You're just using one amount. So that's all there is to a thermal power station. We start with the furnace, we burn some fuel. That heats up water, it boils water to make high pressure steam. The steam spins the turbine, which is attached to a generator. The generator is basically a coil of wire spinning in a magnet. That makes the electricity. This is the important bit. The electricity we make is then stepped up with the voltage to make it a higher voltage, and it's then carried off to the national grid, which is then distributed to your home. So every thermal power station works on this basic principle. Nuclear power stations are really, really similar. The only thing that's different is here, there's no furnace, it's a nuclear reactor, but have a watch of the nuclear reactor video if that is needed for that one.